Thank you all for joining. So, welcome to this webinar. As a part of initiative Happy to Help, we conduct a webinar every Saturday, 7 to 8 p.m. Here, the idea is to, we are requesting everyone, whoever is interested in sharing their expertise with others. And kind of, we are conducting this webinar wherein subject matter expert will come and talk on certain topic. So today our topic is problem solving using data structure and algorithm. To introduce Shubham, he is working as a engineer with Enterprise Minds, and he is one of the awesome engineer I've met in the recent times. So he is really good in data structure and algorithms. He has his own YouTube channel where he has posted a few of the videos which he has recorded on data structure and algorithm. And also he has a blog which you guys can follow, wherein you will get to know more about Shubham. So yes, thank you Shubham for taking out time. So please let's start. Over to you. Thank you.
Thank you. So before starting the session, I would like to introduce myself. So I started my journey as a backend engineer. I worked on Python frameworks. I have worked on C# frameworks too. So, but after that, I got a chance in front end projects. So I thought of giving it a shot. So I moved into front end, and I really liked it. So now I'm working as a UI engineer at emines.ai. So yeah. So now we'll start the session. So in this session, the topics we're going to cover is we'll introduce problem solving. We'll also know something about data structures and algorithm, and after that, we'll debunk some famous questions which are mostly asked in interviews. And at the end, I'll solve a lead code problem that is a medium level problem. So we'll solve that. Yes. So by the word problem solving, can anyone tell me what do they think when they see this word for the first time? Or like someone ever went into problem solving, or they compete in online platforms or something like that? Can someone tell me?
Yeah, Shubham. I mean, I tried once on Hacker Rank, I would say. I mean, related to data structure and algorithm, and I saw there few real-time problem which we never think can be converted in a way to solve using programming. And so I saw some real-time problem. So that is what experience I have personally. Maybe somebody else would like to talk about something related to data structure or algorithm or problem solving.
Yeah. So I'll continue. So what problem solving is, basically it means that if you have a problem, you have to identify the problem. You need to find the solutions to the problem, and then among those solutions, you have to select the solution which is best for that situation. So that's the gist of it.
Right.
And yeah, so these are the points. You can have a look at it. But basically, what I said, that's the basic meaning of it. And so we'll move to data structures and algorithms. So anyone ever in their college time, or after the college also in professional career, must have used simple data structures also, right? So can anyone throw some insight on this?
Yeah, I mean, I will request somebody. So, Akhilesh, am I audible?
Yes, Om, you're audible.
So, could you please talk something about what is your understanding when you hear this word data structure and algorithms?
Okay, so this is something when we start to think about some problem, or maybe we decide to you know, start writing codes, then initially we have to decide that which kind of data structures we want to use for a particular problem. It could be a complex one, it could be a easy one, and that would decide that how easily we're going to solve a particular problem. So that's what that was the first thing that came to my mind.
Uh, that's like you're very close. So data structure is something like as you said that before any solving any problem, we need to think that which data structure is uh, like we what data structure which we can use to store that data or retrieve the data so that that could be done efficiently. So we need to decide that before solving the problem, right? So that is data structures. And an algorithm is just some steps, some instructions so that we could solve that problem in efficient way. So yeah, some that is data structures and algorithm.
Yeah.
So
Sorry, Subham, to interrupt you. Abhishek, would you like to share some of your experience on data structure and algorithm? What comes to your mind if you hear about this?
You're talking to me?
Yes, yes, Abhishek.
Okay, so basically, what I understand is, and how I would define is, algorithms are how you would solve a problem, and data structures are basically the tools for solving that problem. So basically, and you cannot say that algorithm is more important than data structure or vice versa. So it's like they are connected. So some algorithms can only be used with only few data structures, and it's also that if you use incorrect data structure, your algorithm or your solution is sometimes useless or inefficient, or sometimes doesn't even work.
yes, so I'll move forward. So these are some common data structures which we might have at least used once in our life. So you might have heard about array, linked list, stack, queues, hashable trees, and like I have some questions on heap. Can anyone tell me why we use heap instead of using an array? So heap is like we can there's two types of heap, right? Min heap and max heap. So we can store a sorted data in array also. So why we use heap? Can anyone tell me?
So here I would like to highlight something. My name is Pradeep.
Okay.
Uh,
Hi Pradeep.
so hi. So when we talk about these data structures, right? Whatever you see here, array, stack, queue, hash table, tree, or heap. These are basically essential part of the programming thing. Whichever programming language you use, those something will come up with the language itself. For example, when you're declaring a variable which is and you are not allocating any memory to it, it always goes on the stack, right? And when we are allocating it, it will go on the heap. So that's way how the compiler and your linker and the loader that's running your program has been designed for this. So stack, like you are stacking up something. Heap is like you are allocating dynamically something. Now if you talk about array and the heap, so array is like sequential data in maybe sorted order or maybe unsorted order. But when we talk about heaps, I think here heap means you mean to say it's a min heap or max heap, right? So in min heap
Yeah.
or max heap, internally it maintains something like a tree kind of structure where root is always pointing to either min or to the max. That's how this min heap and max heap works.
Yeah,
So
so you are correct, but
yeah.
like I would like to show something. So heap can be implemented using array, and it can be used like a tree also can be used to implement heap. But like suppose what I asked was is we can store like this is a sorted array. So suppose this is a sorted array, and we can store this in a heap and in an array too, right? But why do we choose heap rather than choosing an array?
I guess
So
in A, the time complexity is high, I guess, as compared to heap.
like the time complexity is high for some operations, but you have to say that
Like
because
sorting, I guess.
sorry.
Like sorting operation. You're
So no, suppose the heap is always sorted, yeah, right, and the array is also sorted initially, and
So when you insert or delete any element in the array, you will have to always resort it. Where in the case of heap, you are just maintaining the root. So everything inserts and deletion will be taken care of by these operations, right? It will be doing in log n time, where in this case it may be your n log n,
no,
right?
no, yeah, yeah, yeah. That's correct answer.
Yeah, I
So
think Abhishek is saying memory heaps are not related to min heap or max heap. They are just name
That's
same.
correct.
yeah, yeah, yeah. But I was talking about min heap and max heap. So yeah. So like what he said was correct. So what happens is suppose we have a data incoming that is 10, and we want to insert in it in this array, and not 10, suppose that is minus 1, okay, minus 10. So we if we find the position of inserting this element, it will be inserted at first, right? And in array what we have to do is we have to shift all of these to the next position, so that would take uh, n like yeah, so that will take O of n, like a linear time again, so right, so there will be a overhead. But what will happen in mean heap, this operation would only take log n. So yeah, so that's why heap is much better if we don't know, like if we have a data coming again and again. If we have a fixed number of data, then array could have been a better option. So yeah, so that's about data structures. So like these are some common algorithms, like sorting algorithm, searching algorithm. There's dynamic programming, there's greedy algorithm, there's divide and conquer too. So yeah, so, do you guys know some greedy algorithms?
no, I never heard of it. So could you elaborate a bit about it?
So yeah,
I
so
think you have a choice whether you can take it or you can leave it. That's like something like knapsack, right?
yeah, it's a greedy
Yeah.
algorithm, but the thing is, what happens in greedy algorithm is you have to find the in every step we'll find the current optimal solution, and at the end of the solution we'll get the global optimal, so that will be our answer. So that is a greedy algorithm. Yeah. So and I think you might know about sorting, searching, and dynamic programming is like suppose there is a number of possibilities, there are n number of possibilities to find the solutions of a question, of a problem. So what we can do is, if we are hitting that sub problem again and again, so we can store that answer of the sub problem, so that we can avoid computing that sub problem again. So that is something like dynamic programming. Yeah, at the end we'll solve a dynamic programming question only, so you will get to know more about it. Debunking famous questions. Okay, so reverse string. So like, can you guys tell me how can we reverse a string? Number of ways, like different. There can be different ways, right? So I'll list down the ways, and you guys have to tell me the ways.
You can do it from like back, like say if a string is having element from 0 to n minus 1, you can taking start from end and start putting from on the front side.
Sorry, can you repeat that again?
So say if your string is having element from say 0 to n minus 1, then you take an element from the end like n minus 1 and put it onto the 0th index, and you can do both way, like uh, reduce the index from end and increase the index from start and just insert those things.
Okay, so
It will reverse.
what you are telling is we'll have a pointer at the start and at the
A
end.
2 pointer, yeah.
Yeah, so we'll have two pointers, and we'll swap the values from the starting and the ending index, right? And we'll decrement and increment like every time we
Yeah.
swap it, right?
Correct.
So
Yeah.
what you are telling, right? Two pointer swap. So that is an option, but there is a catch on that. So we'll know about that later.
You have
And
to stop in the middle, otherwise you will come back with the same solution. Like starts will be less than the end. Other could be
Yeah.
using a stat, that you can use a stat also for the same thing.
Yeah, but there is some different catch. I'll tell you that. But is there some other solutions? Can you guys?
Yeah, so we can split, then reverse, then join. This is
Yeah, recursive method you can use like with two
split,
elements.
reverse, then join. So
Yeah.
that's one other way in JavaScript.
Yeah, we can do that too. So like there's one more way. What we can do is we can traverse from the end. Like we'll traverse the string from the reverse, not from the starting index, and we can append that to a string. We can do that, right? Right. Let's traverse from the end and append. So we can do that, but there is a catch in this too. So I said string, right? Reversing a string, but like initially what I got was we can swap it, but you can't swap a string because it is immutable, right? You have to change it to a character array. Character array, so that
If
you
you
can
go
swap
by
it.
the definition of a string, then you can't reverse a string at all.
Yes.
That is only specific to Java.
Yeah. No. Actually, Okay. Okay. Okay.
Yeah.
Yeah, so there is a catch in that. It depends on the language for sure, because in few languages strings are immutable. In some other they are not. For example, in C or C++, strings are not immutable. You
So
can make them immutable. Another catch is that we are talking about strings of ASCII characters. We are not talking about Unicode. In Unicode, if you change the code points, like reverse the code points, it's
Mhm.
completely different character. So we need to take care of that as well. I mean, it's just what you call edge case, not probably you will not face it unless you are working in a production system.
okay. So like what I understood is, so we'll erase this. We'll go next. So suppose we have a string like this, and we want to reverse it. So we can have so the first thing that comes to our mind is like we can the first answer what I got was we can swap it, right? But what I said that we can't swap a string, it is immutable. But in some languages it is not, right? But internally what happens is C sharp, if we append, suppose we have empty string, uh, and in C++, not C sharp, and we append it, like suppose we append A to it. We append A to it. We appended A. Then what will happen in C++, that won't create an extra memory, that will just add it to this only. But in what happens is Java is this will create an extra memory. So S will now point to A, and suppose we add we concatenate one more letter to it, suppose B, then there will be like one more extra memory will be created, and that will be that will be assigned. A and B will be assigned to S. So we'll be creating different variables every time we concatenate, right? So that is the catch here. So if we so what I meant by this is, so if we traverse from the end and append, so we'll be creating strings every time we'll appending it, right? So
You
what we
can
do
use a
it,
different data structure here, no? String builder or string buffer to do this thing.
yeah. I was coming to that only.
Okay.
Okay. So for that, what we can do is we can have a string builder. So this is internally this works as a character array only. So we can append every time we traverse from the reverse, and this won't create extra memory. So that is the So that is the answer to the solution. And there can be multiple answers, but yeah. So that's the thing. And let's move to different question. So stack implementation. So
Shubham,
like how?
sorry to interrupt. There is a question from Dweep. Would you like to take that? Wherein he
Yeah.
is saying that I have a SQL table where dependency of parent and child are set. Do you have a Python code to resolve the parent-child relationship and accordingly highlight the parent row followed by child row?
So
Yeah.
Wait. So, like, can you repeat that?
Yeah, I can do that. So I have a SQL table
Okay.
where dependency of parent and child are set. Okay.
We have a dependency. Okay.
And do you have a Python code to resolve the parent child relationship and accordingly highlight the parent row followed by child row?
What kind of relationship? I'm not getting it.
Do we, can
It's
you,
what
yeah,
so
sorry.
basically these are jobs relationship. So basically how you set it up in a control M, right? This is my parent job and these are my child jobs. Now those are stored in a SQL table, right? Now I want a Python code which actually resolves this relationships and then runs the parent first, followed by the child in parallel processing. Okay.
Okay. I got it. So, what is it? We have a dependency from parent to child. So, before running parent, we can't run child, right? So, that is the dependency.
That's right.
And that is something like topological sort.
Yeah, topological sort. So, this will be a directed graph, and topological sort will give us a order so that we'll get the desired, like, yeah, so we'll get the order. So, by which we can execute. Yeah, topological sort will do that. You got your answer, right?
You'll have to write your code by your own actually in
Yeah, but
Python.
yes. Yeah, thank you, Shubham. Yeah, that answers the question. Thank you. Yeah, you
Yeah,
can.
yeah. Thank you.
Like, I haven't worked with Python for like 2 years, so it'll be a little difficult to write code in Python. But yeah, I
Yeah,
can do that.
yeah.
That's fine. I was just trying to understand the logic, how it can be done. Like,
Okay. Yeah.
origin. Yeah.
So yes, so now we'll solve a lead code problem. So this is the problem. So I'll read out the problem statement. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. That means the first house in the neighbor of the last one. Meanwhile, okay, first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given the list of non-negative integers, nums, representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So this is a problem statement. Did anyone get it? Or I'll explain it. And I'll. So. And I forgot to ask one question too. So I'll ask it afterwards. Okay. So what the problem is saying. So we'll have a array. There'll be a nums array.
Are you sharing your screen?
Yes, you can't see it, right?
Yeah, we can
Can
see
you
it. Maybe you can pin the screen, Sanjay. You need to pin the presentation. You'll be able to see it.
Okay, thank you.
Yeah.
Okay, so suppose we are taking this array as an input. So we have this array, and what like the problem is saying is, so these are houses like money stash. So these are houses 0, 1, 2, 3. So there are 4 houses, and these houses are connected in a circle. They are arranged in a circle so that the first house is connected to the last house. So suppose the first house is here, the second house is here, and fourth house is here. So the last house is connected to the first house. Okay, and these are the money stashed in it, and we need to find the maximum amount of money which the robber can rob. Which the robber can rob, and there's a constraint on it is that suppose we rob the first house, then we can't rob the adjacent house. Yeah, so if we rob the first house, we can rob a house like the next house, next to next house. Okay, so we can't rob the second. Suppose we rob this, so we can't rob this. So we have to go here only. We can rob here, right? So by this possibilities, we have to find out the maximum amount he can rob. So did anyone got the question?
Yes, yes.
There is one more constraint, so that if he robs this house, then he can't rob the last house, right? Because if he because in the question it is given that the house is arranged in a circular manner. So if he robs this house, then this will be adjacent, right? So there's one more constraint in that. So so do anyone like to share the solution, or should I explain it?
Yeah, so I want to try.
Okay.
So what we can do, we can start from like if there are not a single thing inside this array or zero houses, maybe that would be a scenario if n equal to 0. Then in that case we could return 0 amount, and if the houses is 1 or only 2, then I think, in case of 1 we can return the house 1 amount, and in case of 2 houses we can return the highest of 2, and if it is more than 2, then I guess yeah, then we can run a loop, and we can check the highest of the 2 values, and we can return the sum at last. I guess means this is how we can do it.
Like we can do it like that, but that's not the actual solution. What you were trying to say is a greedy approach. So that is actually not that intuitive. So I will not cover that. So I will cover the recursive approach and the solution. Like after that, we have to memorize it. So the timing programming approach. So I'll cover that. So anyone else would like to try?
Yeah, these houses can be any number of we don't have any fixed numbers, right? It can be
Yeah.
odd even as well, right?
So, house, these are the number, like these are index. Suppose so array starts from 0, right? So suppose this so this will be 1, 2, 3, 4, 5. So there'll be four houses. So there can be n number of houses, and these are the money which are stashed in the house. So the robber has to maximize the money he can drop. That's the question.
Yeah, I know. I got the question. Only problem even when we have odd number of houses,
Mhm.
then it become difficult. Yeah, we can either first we should check whether we have odd number of houses or even number of houses, and then we should check first value and the last value, which is
But
greater.
here it's a circular, na? So you don't know first and last. That will be the problem.
Uh, no, we have the array. If we look at the array, we have
This
the
array is circular array. So every other house will have a burglar alarm.
Okay, is it a single linked list with a loop? Is it?
You can
It's
think
a-
of that thing.
It's you can think it like that, but it's actually an array only, and we have
Okay.
to consider that last is attached to the first.
Okay. If it's a single list with linked list with the loop, then I don't know. But if it's an array, so if we have the even number of array, then either we do the sum of the odd places and even places, and calculate which sum is greater. So rob that way, and otherwise,
But you can skip the house also, na? So that sum of odd and even will not work out, because you may want to rob after 2, 3 house also.
Yeah.
Based on the values.
Yes. So okay, continue.
Okay. Otherwise, I think if there are odd number of houses, then connection. Then first check which first house or last house have more money, and skip which have less money, and then we'll do that.
Actually, that will not work. What will happen is we'll have some of the possibilities which we haven't explored, so we will not get the actual output. So I'll explain it. Okay. So we are at the starting index, right? And we'll have two possibilities here. So robber has two possibilities here. Either he can rob the house, or he or she can not rob it. Right. So we can have two possibilities. If he robs it, then he'll have one, like the current money. Let's take it as CM. So that'll be one, right? If he robs it, then that will be one. If he doesn't robs it, then that will be zero. This will be zero. So I'll write it here only. I'm removing this. This will be one, and this will be zero. So now from here, if he robs it, then he can't rob the adjacent house, right? So from here he can only move to the third house, which is this. So we'll move to the third house, and here then again, when we move to index 2, we'll have two more possibilities. So he can rob here, and he can not rob here again. Right. So these are two more possibilities we can have here. So if he robs here, then that will be we have one because we came from this possibility. So we have so the money he has currently with him is 1. So 1 plus 3 will be 4. If he robs it, if he doesn't, then he'll have 1 only. Right. And from here again, if he robs it, then we'll find other possibilities. We'll go to index will be 4 here, so we'll go out of the loop. So we'll have a base condition from where if we go out of the loop, we'll return 0. And if it doesn't drops it, then we can move to index 3, and we can check if checking with third house 1 plus 1 2 gives the maximum or not. So we have to find different possibilities. Okay, so I would explain the time. Did you guys get it? What I was trying to say?
Yes.
Okay, so I would try to explain the time
So is it
complexity.
like greedy approach only, right? We are either choosing or not choosing it.
This can be solved using greedy, but this is actually this is a
So what you
recursive approach.
explained is that another recursion is a way by which
Yeah.
greedy thing, right? So you're saying, say, for example, we choose the first house, then anyway we can't choose the second house. There is no choice.
Mhm.
Then after that, like n plus 1 will reach to third house. From there, again we can have either we can select it or we don't select it.
Mhm. Yeah,
And then we do a sum and do a max of it, right?
Yeah. At the end, we'll get all the possibilities, right? The current maximum or the current money he robbed. We'll get. We'll explore all the possibilities. We'll get that in the end, and we'll maintain a global maximum, and we'll add. We'll just update the global maximum. It is if the current maximum is greater than the global maximum. Okay. So that will be it. And if I explain the time complexity of this would be so every time in the array we'll have two possibilities, right? So from the first position we'll have 2, from the second we'll have 2, third we'll have 2, and suppose the array size is 4, so we'll have that. So that will be like 2 to the power of 4. So suppose the n size, suppose the array size is n, so that will be 2 to the power n. Now this will be an exponential approach, right? So how can we optimize this? This can be solved. Like there is two approaches. One is dynamic programming, and the second approach is the greedy algorithm. So we'll see the dynamic programming approach. First, we'll solve it using this only, and I'll show you how this will give a time limit error. So we'll solve it like that. So I'll have a util function. It'll have num. I'll pass the index. Initially it will be 0, and I'll pass the flag. I forgot to explain one thing, that these are adjacent, right? The first and the last one is adjacent. So we have to know that, like we need a way to know if he has robbed from the first or not. If he have robbed from the first house, then he can't rob from the last house, right? So I'm just maintaining a flag for it. So yeah, so that's that. So initially the base condition would be if index is equal to or greater than equal to nums dot length. If it's out of bounds, so we'll return the 0. We'll just return 0. If it's not, then we'll check if so at the end we'll sometime we'll reach the last house, right? And at the end we have to check if the robber has robbed from the first house or not. If he has, then we have to return 0. So if he has robbed, so I'll check if I'll make the flag 1 if he has robbed. So if he has robbed and the index is and the house is the last house, then we'll just return 0 because he can't rob that house. Okay. And if this condition is not met, so there can be two possibilities. Either he can rob the house or he can not rob it. And we need to return the maximum of both the scenarios, rob and not rob. So if he robs the house, then he'll have that money in his pocket, right? So we'll add that and we'll look for the other possibilities. So we'll go, we can't check with the next house, adjacent house, so we have to move to leave the second house and we have to move to the third house. So we'll do a +2 here. And in the flag we'll check is if the index is 0. So if that is the first house, then we'll check if if he robs it, then index is 0, then we have to send 1, right? So we have robbed from the first house. If we other than that, we don't have to check anything because at the end we for the last house we only need to check if he has robbed from the first house or not. If he has robbed from the first house, then we'll get the flag as 1, right? And if he doesn't, then this will be 0 only. Okay, so that flag is for that only. Yes, and if it doesn't robs, then we'll just skip it and we'll move to the next index. And flag will be the same. So I'll just check it if this is fine or not. So
Max will be small m, I guess.
this is C#. In Java, it is small m.
Yeah.
In one of the the second if condition, I don't do coding in C#, but the first if first condition, if index equal to or it's index
Yeah,
equal
it's
to.
equal to. Yeah.
Yeah, I think
That's
you are
right.
assigning the variable if you do. Yeah.
So here, tell me one thing. In line number 10, if this is the condition, then can it go in the seventh line, or it cannot never go there?
No, it won't go there if the flag is 0, and if the robber reaches the last house, then he'll return from there only because there won't be like he can't rob the last house, right? So you have to return from there.
No, I'm saying this here we are checking for the length -1, and there it is greater than or equal to length. So length can go actually till the length only, na? Nums dot length. Index can go up to this line only.
So what
So
happens
you're
is
doing a
if
plus 2, that might cause that, I guess. That's all, right?
what
You're
what
doing a
plus two?
plus 2 on line number 13, index
30.
plus 2.
So I have a base condition for that also, right? If index
Yeah,
is greater than lunch dot length. So initially I'm only checking that. So that won't cause me a index out of range error. That is why we have base conditions in recursion. Okay, these are the most important thing, and the possibilities we can find. These two are the things, but and recursion will find everything. Just you have to know these stuffs, and this will come like if you solve like 1 or 2 months extensively, you will get to know this stuff. This is not that difficult. So yeah, so I'll try to some run and check this if this works or not.
So it's kind of early return pattern, Shubham, right? The one you wrote at the start, sort of.
no, this is
Not
termination of your recursion.
It's just a base condition. When we
Okay, okay.
meet this condition, we just have to return this. Suppose we don't have this condition, okay, and suppose the length of array is 4, and if we do an index plus 2 from third index, so we'll reach 5, right? So we'll reach 5, and what will happen is when the program comes at this line and we hit this position, then we'll get an error index out of something like that, right? We'll get that error
Got it. Got
index
it.
out of bounds. Yeah. So we'll have this base condition just to avoid that.
Got it. Yeah.
So this I'll put one more test case in. So this works, and so like this will give TLE. I like previously told, right? I shouldn't have told it. So I thought of asking it, why will this give TLE? But I have said it. So this will give TLE. I'll submit it and I'll show it to you. Time limit exceeded. So what happens is this is an exponential approach. Okay, so what I said, and to optimize it, we can use dynamic programming. Like we can use dynamic programming. So what happens is, suppose the array is. So do like can anyone tell me how can we solve this using dynamic programming?
You will remember the result of the last calculation.
Yes, that's the gist. So what happens is, suppose we have some element here, something. So we have two possibilities every time, right? So it can happen that this position can be hit many times, right? We can reach this position many times because we have multiple possibilities. So we can hit this index many times. So after, if we don't cache the problems, so if we don't cache it, though we will have to calculate the value from like we'll calculate all the possibilities from here again. So we'll have two possibilities here too. So we'll have to calculate that again. And if we store it, then we'll prune that. So we'll prune that possibilities and we'll just return the answer from here. So this can happen. So by dynamic programming, we can cache the problem, cache the intermediate solutions. Did you guys get it? I shall explain. I can explain it through code also. I'll code it, but yeah, did you guys get it?
Yeah, Shubham. I mean, I was able to understand. Yeah.
Okay.
Yeah, I got it.
Okay. So for dynamic programming, so I'll have an array. I'll explain it why I'm taking as a two-dimensional array. This would be nums of, and this could be 2. Yeah. So I'm taking this as a two-dimensional array because so we had a flag here, right? So there could be like two scenarios. If he robs from the first house, then the flag will be 1. If it doesn't rob from the first house, then the flag will be 0, right? So for that scenarios, we have to check also. So I have this. This will be the flag. This will represent the flag, and this will represent the element in the position in the array. For that position, we can find the solution. If we found the solution before, we'll just return the solution. If we haven't found the solution before, we'll look for the solution. So initially, what I'll do is I'll just fill the array with uh, what do you call it? A garbage value, so that we don't hit it with that value. So I of 0 should be -1, and I of 1 also should be -1. So we got that, and we'll pass that dp so that we can use it in our utils. So yeah, so we passed it, and now here what we have to do is we'll check if at that index and if we have that flag, so that is -1 or not. If it is -1, then we have to calculate further. So we don't have, because we set a garbage value for that, right? So we have to calculate further. If it's not -1, then we'll return that. So we have a cached value, so we'll return that. And if it is -1, so it will come down, right? And after finding all the the answer, we'll just store it for the next time so that we can use it. So this will go up, so we'll store that in the dp so that we can use it afterwards, and we'll return that. So this will not give us TLE. So yeah, and if I explain the time complexity of it, sorry.
Yeah, I think
Yeah.
go ahead, Shubham. There was some.
Okay,
Yeah.
okay. So let me check if this runs or not. Then I'll submit it. So what is wrong? Database variable. Use like a type. Okay, okay. So this should be int. Okay. Mm-hmm. Oh, so like this, if I write is like this, right? This is a what do you call it? Jagged array in C#. So, and this is a two-dimensional array. Again, I wrote here also. Okay. So yeah, this works, and if I submit it, this will work. I think I'll explain the time complexity. So yeah, this works, and this is not the fastest solution because there is a greedy solution to this also. And don't take this, like lead code is very random. If you submit it again and again, we'll get some more answers. So I have tried this before also. So that's that. Yeah, so like I'll explain the time complexity. So we have array, a DP array, right? So we made a DP array of length, like the, if n is the length of the array, so we have n and comma 2, right? So we have that as an array, and we can ignore this 2 because it is a constant, right? So the time complexity here will be O of n, and the space complexity, as we are taking uh, yeah, we're taking extra space as the dp, so that will be of O of n again, because, and we'll ignore the constant. Yes, so yeah, that's all. That's for this question. Did you guys get it?
Yep, it was a good one. Anybody has any questions, any clarification if you need, please ask. I think everybody understood.
Okay.
So yeah.
So like, I don't have anything else left. Yeah, I had one question too, so I'd like to ask that.
Yeah, I think somebody has a question. Divyansh, you wanted to ask something? We can't hear you, Divyansh. Are you speaking? Um, yeah, Shubham, I think you should move forward. Yeah.
Yeah, so initially I asked about like stack, right? The data structure slide. I asked about stats. So stacks can be implemented in 2 ways, right? Array and a linked list. So can anyone tell me which is a better approach? Like, is there a is arrays better or a linked list is better to implement stack?
Ganesh, would you like to answer that? Maybe Anu? My answer would be linked list, because it has a reference maybe. That's why.
So I am getting a.
It will depend on your data set size. If it is too huge, then linked list will be preferred. If it is too small, right? Maybe a couple of hundred numbers, then array would be better.
So you're somewhat close. So there is no better option
Right.
that you have to select linked list. So
Sorry, was that a question for me?
Yeah, I was just wondering, but that's okay, Ganesh. I think somebody answered. So yeah.
Yeah, so what I was saying was, I mean, if you want me to answer,
Yes, yes,
I'm sorry,
please.
I didn't hear that voice clearly. So what I would say is, I mean, first of all, recursive programming is risky if you don't understand the length and size of the data that you are processing,
yes,
because your system stack can overflow, and that's a
yes,
very bad thing to do.
yes.
So first of all, my suggestion and my choice always is not go with recursion. Uh, because if we don't know beforehand what is the data that we are dealing with that our program wants to process, then it's risky for the system. You will run out of the memory for the program.
Yeah, yeah.
So I mean, if I hope that answers the. I mean, it it basically answers you don't use the stack. So it doesn't. Your question doesn't remain then whether you want to implement a stack using array or linked list.
Like I didn't get the last part. Like,
So, in real life problem solving, I generally don't prefer recursive algorithms unless and until we know what type of data and how much big data that we are processing. And in today's world, if I understand, we don't know, right? Like if you understand the real problem statements and data processing, you will see that you don't know the data beforehand. You'll come
yes,
to know at the runtime what data is processed. So using recursion or using stack, system stack is risky, is what I'm saying. And if I don't want to use recursion, I don't need to deal with the stack. And then if I don't need to deal with the stack, then I don't need to think about how I will implement the stack. Something like that.
so it's not that if we are using recursion, then only we are using a stack. We can use a stack.
No, no, yeah, I understand your point. What I'm saying is, I mean, if we are really solving a real life problems, then it's a very rare possibility that we will go with the recursion.
Okay, okay. Like that wasn't my question. So like I asked why like why the stack
Could you please
implementation?
repeat? Yeah. Could you please repeat the question? Yeah.
Yeah. So like for stack implementation, we can use either array or linked list, right? So
Mhm.
which one is better, and if anyone is better, then why?
I would again say that depends on what type of problem you are solving. I mean, one has advantage over other, and other has advantage over the first one, and something
Mhm.
like that. So we can't really say which one is better. It all depends on the type of problem that we are solving. I mean, that's at least I think. I mean, I could be
Yeah.
wrong, but
Yeah.
that's what my understanding is.
Yeah, it depends on the problem, and I think recursion is not that like it's bad because we are using we are that we'll have a stack trace again and again in recursion. So dynamic programming is much better with if we have a iterative solution. So recursion is just that it comes to the intuition. So that's why we use recursion when we like initially understand the problem. So we use in recursion, then we optimize it with memoization, and then after that when we get the relation that we can solve it like iteration, so we solve it iteratively only. So that's the thing, but dynamic programming is most
Okay.
efficient with iteratively only. It's most efficient
Okay. So
iteratively.
if we have a couple of minutes, and if you guys permit me, I would like to share the real life problem that I faced with the recursion and that I solved without recursion. So
Okay.
I won't tell you the name of the company or something for which I was working that time, but I'll tell you the problem. Say, for example, I'm processing a HTTP request, right? And it's a SOAP request. So when they designed an approach to process and parse the HTTP SOAP request, it was a 2 MB request that time in the old times, right? There was not too much data coming in the SOAP request or something like that, and they had a parsing algorithm written for the tree, right? Tree data structure. And tree data structure, if you want to pass, you will keep on storing and going down the length till the last node you hit. And in case of a core security product or core security product, in that case you need to match and parse each and every character that is coming to the SOAP request. You cannot allow going it back to your production server with that request, right? So you can't really miss a bit, but you still need to parse everything. And if your SOAP request keeps on growing, and nowadays HTTP request goes increasing, and the old approach that those guys had was only up to processing only up to 2 MB, and the implementation with the tree structure was fine. But later on, what happened? As soon as the new data flow coming in, large size of data being processed, and all that stuff happening, it started happening that this program had a tree parsing, had a recursion algorithm in that, right? And when that recursion came in, after 20 MB request or 25 MB request coming in, this system stack started running overflow, right? And some
Mhm.
overflowing, and it crashed the production system. The system that is in place to actually put the security on the backend server, it itself crashed, and every request was going directly to the server, and nobody noticed it in the live production for 2 days. When server was under attack, then we realized the processing of the request that was happening through a security tool is not anymore handling those type of requests. And when we narrowed it down, we figured out that recursion ran our system overflow and our system crashed.
Okay.
So I mean, this is the real life example I'm telling, and that is the reason the initial answer that I gave, I came up with this background. That's the reason I told you I don't really like the recursion.
So it's like it's I can understand it, but the thing is,
And
if you can,
it all depends on the case by case basis, basically. I mean, you can't really have a fixed solution to particular thing. We need to
yes,
understand what kind of a problem we are dealing with, and then we can decide which data structure or which algorithm that we can go with, something like that.
yes.
I mean, at least that's what my understanding is. I could be wrong, and other people might have better ideas than what I'm saying.
So I would like to add something. So you said that the data you were getting was a tree kind of structure. So you had to like the tool was traversing that tree recursively, right? You said that.
Hmm.
So
Hmm.
what we can do is we can also traverse a tree iteratively also, and depends on what
Yeah, yeah.
traversal.
We solved that problem. I understand. See, we solved the problem by iterative way. The example that I gave, because initially when they implemented in the old times, it was implemented with recursion. We
So
solve the
that
problem just by removing the recursion and doing iterative approach.
okay, yeah, okay. So that's that. So like that
I
was
just wanted to give an example of why
I
recursion is
I
unhealthy
understand.
basically for the system.
I understand. And I would say again that wasn't my question. This question was like why we should choose an array or a linked list to implement a stack. Stack as a data structure, not a stack that call stack which we get when we like if we debug we see the call stack, right? Not that stack. Data structure stack.
Abhishek, would
Where
you like to answer that? I hope you got the question. Abhishek?
Yeah. Hello.
Yeah.
Uh, I didn't get the question. Sorry.
Okay.
What's the question? Can you repeat?
So actually,
okay.
earlier as well, I had
Okay,
the
that's
question
enough.
was confusing to me. The reason I answered the way I answered is I thought you were talking about the stack in
Yeah,
the system.
that's why I cleared
Yeah.
it this time. Yeah. So yeah, so I'll explain it once again. The question. So suppose there are data structures like stacks and queues, right? So in a stack, what we can do is we can push it in the top or we can pop it from the top. So in that data structure, like what would you choose, an array or a linked list to implement it, and why?
Hmm. Good question. So it depends. So what kind of usage we have. So in we can definitely do it using linked list and array both. Linked list I think would be much more efficient, mostly because you can always pop from head on O of one, and you can insert in O of one as well. So you don't need to worry about the linear time or any such algorithm. Uh, in array, it also depends because it's not difficult to implement the O of one in array as well. So, for example, in JavaScript, if you push at the end or if you pop from the end, it's always O of one operation. But if you do it from the head, it will be in O of n operation. So that's basically it's sometimes confusing. So it's better to do it using linked list for better memory efficiency and better runtime efficiency as well. Does it
So
answer the question?
like it was very close, not like totally correct, but I would like I would add to it. So what happens is nothing is better, array or a linked list. Nothing is better, and you can use array or you can use linked list both, but it depends on the situation. That if we know the data, suppose we have 10 data only incoming, so we can define the array size to be 10, so we can so the that it will not overflow also, and we can push or pop. That will be of one operation only. So we have to implement it that way. That will be of one only. And what happens is if we don't know the amount of data we are receiving, then we can use linked list. But the problem with linked list is in linked list we'll have like a node defined to it, right? Every time we have to go inside the node and we have to access the value. So it is little bit slow, a little bit, not that much, but it array will be most like a faster way to access the values. So nothing is better, array or linked list. It depends on the implementation what we are implementing. What is the problem? So it depends on that only. So that's the solution to this. Yeah,
Okay.
and mhm. And like I don't have anything else to say now. I think
Yeah.
everything is yeah.
Sure. So yeah.
So that is my Instagram handle and the YouTube channel. So this I don't have a user in India, so I can't give you that. This is the uh, random generated value which they said. So you can search for best keyword there. So yeah, this is my channel name. But I haven't added videos from last 1 month. But you can have a look at the channel too. Yeah, that's all from my side.
Yeah. Thank you. Thank you, Shubham, for taking time out and sharing your expertise with all of us. Thank you all for joining. Actually, we started this initiative during pandemic. Idea is to motivate others to share their knowledge, expertise, and experience with others. Kind of every Saturday we conduct webinar 7 to 8 p.m. IST. You don't have to be expert really. You just have to be willing to help others, I would say. All the sessions which are being conducted here, they are recorded and you can find them on our YouTube channel. There is a meetup of wherein you can follow us and you will get the notification of all the webinars we are conducting every Saturday. The other format is one-on-one mentoring. So you can visit our website to find out mentors and check their calendar to schedule free one-on-one session with them. If you're interested, you can also register as a mentor and help others. So yeah, this is about initiative, and again, I would say thank you all, and especially thank you, Shubham. If you'd like to add anything, over to you.
Thank you for joining, guys. This was my first presentation. Like, yeah, between like this many people, and like, I think I am the smallest here. I think in terms of experience, I was kind of nervous, but yeah, it went well. I think. Yeah.
Yes, it went awesome. Trust me on that, and that's the idea. You don't have to be really expert to talk on any given topic. So thank you so much, Shubham, for even taking this up that I'll conduct the webinar, and yeah, and I think everybody would agree to that.
Yeah, thank you, Shubham.
Thank you.
Yeah,
Thank you.
thank you, Shubham. Ganesh here. Yeah, I really appreciate you taking this seminar. Thank you.
Thank you. Thank you, Ganesh. Thank you
Yeah,
all.
appreciate your effort, Shubham. It doesn't look like you are doing it for the first time. Keep
Thank
it
you.
doing. Yeah.
Yeah.
Yeah. So yeah, thank you all, and have a good night and have a good weekend ahead. Thank you.
Yeah. Good night. Good night, guys.